Okay, welcome. Now, I've cast this mold here, and it's a riser for my rotary table. As you can see, it's got a little bit of draft in the sides here, and a wide angle on top. Reason for that is I've made the base to suit my table of the milling machine, and the top is as wide as the rotary table. So when I set it down on the table, everything should be a matching pair. I made it a little bit oversized. It doesn't matter. Okay, then I've got two tabs here on the side. Now these tabs will be used to clamp down the rotary table to the riser. Okay, now what happened when I cast this mold? Right here underneath the hollow sections, it bulged a little bit towards the outside. And because of that, you can't set it flat on a flat surface. It rocks like crazy. So I've installed my engineer's parallel underneath the riser on top of two 123 blocks. Now, if you don't know the HQ800 machine, you only have 100 millimeters of coil travel on this machine. It doesn't have a knee that can raise. So whatever you need to machine, you need to bring up to your coil as much as possible. Now in this case, my rotary table is going to be short by around 30 millimeters for gear cutting, but I've opted to raise it by 60 millimeters. So that will give me a little bit of room for finding center of gears and so on. And even normal key cutting can also become a challenge if your end mills are a little bit short. So this will be a great help for me. Now I've got an option to use it or not use it, so but I need it. Okay, so my plan of attack here is to mill the section here between the two tabs, and then flip it around on top of the 123 blocks, and then machine this side here at the bottom, and then flip it back down, and then check if I've got parallelism between the two surfaces, whether the surface is true to this one after I've machined this section here. Now, beam castings is quite difficult to get a setup in such a way that you can run both surfaces and clean them up simultaneously in one setup. And every time you flip something around, there's a possibility that you can lose position or your parallelism, and also a risk of having castings of uneven surfaces like this is the fact that your casting can bend as you clamp it down, which I seriously doubt it will happen in this case because of this supports and stuff on the inside, but anything is possible. So I'm being cautious here. So I hope you enjoyed this video, and let's start. I've removed 0.2 millimeters of the surface. I see I still have a low spot here, so I'm going to remove another, I would guess another 0.2 millimeters to get this cleaned up. This I've fed by hand and it's reasonably smooth. So the next section I'm going to do with power feed. Okay, it may look rough to the naked eye, but it's silky smooth. And it should be able to see it properly. There's still a little bit of inclusions there in this section here, but that doesn't really matter. The outside surface is a surface that really matters. I feel no rock, so I believe this surface is properly square or flat. So I'm going to do the same on the top, remove 0.2 millimeters and see how the surface is cleaned up. If I need to take down more, I'll do that. We need some shorter studs here. Apply equal pressure on both sides to make sure that I don't pull it towards one side. Part is still laying flat, so I'm happy with it as is. Doesn't need to be square to the machine or anything, because it's just an open flat surface. I'm using kerosene or paraffin as a lubricant, just to prevent it from sticking to my milling cutters. Right, need to drop it 0.2. Okay, I've got a low spot shape in a U here, especially on this corner here, so I'm going to drop it another 0.2 millimeters. The reason why I'm only dropping 0.2 at a time is I don't want to overcut and take too much off at a time. I want to conserve as much thickness in this part as I can. Okay, I have etched, found and centered the machine more or less to the center of this entire body, and offset it from the center 45 millimeters to the side, because my T-slots are 90 millimeters center to center apart. So I'm going to drill a hole here and a drill a hole there, and that will clamp this unit down to the table. Now there's no way that I can get a center down this hole, and I'm not going to turn the part upside down to drill holes on that side, because I want to make sure that everything is concentric to this face here. Now if I turn it around, I seriously doubt it that I'm going to get with my edge finder to this edge here at the bottom. Okay, machining is done. I've cleaned up all the faces that's critical. It's only these two corners that's got a little bit, that sits a little bit low, but that doesn't matter. The whole surface here is going to register on the table, so those corners are not very critical. This side, because of the small area where the rotary table is going to sit on, you have to make sure that this whole area is nice and flush. The tabs are not critical. They can sit higher or lower than your machine surface. It's not going to make any difference to the rotary table, as the rotary table is only going to go up to this edge here. These holes have just drilled them by eye from the center line outwards. It was around 54 millimeters in both directions. So yeah, it's also not a critical feature in this bolt. So all you need is two T-nuts, couple of cap screws, and a square. There's a little bit of room for adjustment. So it's not like your rotary table has to sit exactly 100% square on it. It will always happen that when you need a bolt of a specific size, you'll find one that is double the size that you really need, or half the size of what you need, but almost never on size. Okay, if it's not immediately apparent, with the rotary table, if you've got your locating keys installed at the bottom, you always land up with your rotary table hanging off the side from your table if you've got a HQ800, because you don't have a center T-slot. Now, the advantage of this setup here is that you can clamp it in the middle now and have the table resting in the middle of your table. So it's sitting nice and centered to the table, balancing your weight. Okay, as you can see that the coil has been extended fully, and from center up to the center point of the cutter is around 30 millimeters. That's just enough clearance. Now, without this riser, there's no way that you will be able to cut gears with a standard arbor that's going to reach in the middle. Now, this being an MT3 taper, it's not very feasible to extend the arbor, because as soon as you're going to start cutting high module gears, you're going to have flex and possibly bend your arbor right here in the neck or break it. So the best is to lift the rotary table up and then keep your arbor short. So I hope this makes sense, and I hope you enjoyed this build. I'm definitely going to use this thing to do my gear cutting. Now you need to put up a chuck here and everything's standing out, so it will be away from the spindle. And as soon as you put your gear blank on the arbor, it's away from your chuck even. You even got more clearance. Now, with a setup, you don't really need a tailstock to cut your gears, unless you're going to make a long gear. So yeah, until next time, cheers.